Hello and welcome to my Physics 2211 Lab 3. This is the gravitation lab. For the first part of this lab, the system is the planet and the surroundings is the black hole. In the second part of this lab, the system will be the planet and the ship, and the surroundings will still be the black hole. For part 1 of this lab, we were tasked to find the net force on the star for all points in the dataset. This will then be used to find the mass of the black hole. To do this, we defined the variables that would go into the calculation. This included the initial and final velocities and momentums. We also defined the change in velocity and momentum. Using these variables and the total time, which was 86,400 seconds for one Earth day, we found the dp/dt, which we used to calculate Fnet. Then I did a series of calculations to find the Fnet perp and Fnet parallel, which are seen on screen now. After this, we used the force of gravitation formula to define the mass of the black hole. This value will be calculated at every point of the simulation and printed out into the terminal. I then adjusted the arrows of the forces to accurately show the magnitudes of each of these forces. Then, by running the program, we can see the simulation run and the data populate in the terminal. I imported these values into Excel and found that the average value of mass was 1.51 times 10 to the 34 kilograms. Now, beginning part 2 of the lab. I defined the mass of the black hole using the calculation we did in the last part. For part 2, we need to find an initial velocity that will allow us to leave the planet and miss the black hole. To do this, I defined a lot of variables. Shown now, basically, to find the net force on the ship and the planet, I had to add the forces of the two on each other with the force that the black hole does to each of them. I then had to define their velocities and position vectors to keep them updating throughout the simulation. I then used a guess and check method to find a velocity that was less than the speed of light but also larger than the escape velocity. My final velocity for this was in the x direction, -5 times 10 to the 7, and in the y direction, 1 times 10 to the 7. These are both in meters per second. Now, to answer the what does this mean question, I'm going to compare Fnet and dp/dt. So, the force parallel to the motion is equal to the change in the magnitude of momentum times the unit vector p hat. The force perpendicular is equal to the total force minus the force parallel in this case. Therefore, the two variables are not equal to each other, but they are directly related to each other. Now for the what if, for the second part of this lab, we were tasked with finding an escape velocity that was less than the speed of light. Now we want a velocity that allows the ship to orbit the black hole without crashing into the planet. The values I found for this were -8.85 times 10 to the -6 meters per second in the x direction and 9.8 times 10 to the 6 in the y direction. Thank you for listening.